Okay, let's start. I have here the file with the from the group. I don't know which group is. I think it's group 2, no? The one that sent me the file that has the. Let me check here. That has biochar and control. That's group 2.
Yes, doctor.
Yes. Okay, so first of all, I want to make a quick demonstration about how do you analyze this. Let me share my screen with you guys. Let me share the screen. Window. Entire screen. Let me check here. Window. How do I share this? Yeah, first this one. All right. Can you guys see this? All right. Can you see the screen?
Doctor, clear.
Clear?
Yes, doctor.
Okay. So you will see here. I made a demonstration that we have like. This is not the group from the biochar, but just a demonstration because I didn't have the replicates from this group. So you will have here the treatments like NPK and you have control without NPK. For example, and you have different plants, plant 1, 2, 3, 4, 5, 6, and so on. Yeah, and you have any parameter here on the right. Here I put like shoot length and root length. Yeah, so the size of the roots. But you can put absolutely anything here. Yeah. So the next thing I want to show you guys is probably you already know this, but for the ones that do not know, yeah. For example, here you have um, uh, average. Yeah. Let's copy the label first here, NPK and control. Okay, and let's say average and standard deviation. Okay, so let's do here the formula for the average, straightforward, equals average brackets, and you select the data that is from the treatment that you are averaging. Okay, close brackets, enter, and that will give you the average for the treatment. Same thing goes for the control. You just need to select the data that is from the control. Okay, selecting the data from the control, you can drag the region by doing this. So you already see here in this case the average for the NPK is much higher than the control. And the standard deviation, let's calculate the standard deviation, equals, the formula goes stdev, open brackets, and let's select the data, okay, from the NPK in this case, and we can do the same thing for the control, from the range from the control. So you can do this for any response parameter, and what I recommend you to do now is you can show your data by making graphics. Yeah, so the graphics go like insert bar charts, for example, and the bar chart here will be showing the NPK and the control, and the next thing I want you guys to do is whenever you have replicates, you want to show the error bars. Yeah, so click here on the corner, there is a plus. Yeah, there is a plus here in the corner, and you click on that plus, and you're gonna select what it says error bars. Yeah, and then the error bar appears, but you're gonna click on that error bar, and you're gonna right click on the error bar and go format error bars. Can you see that? Format error bars, and that is going to appear on the right. Select custom, specify value, and you go select the standard deviation here, and you select the standard deviation from this one. Say OK, and alright, this is the error bars are reflecting your real standard deviation here on the chart. Next thing I want to teach you guys how to do is in Excel you are able to do statistics. No? You are able to do statistics. But in order to do statistics, you need to organize your data in a different way. Okay, so you need to have, for example, here will be NPK, and here will be control. Okay, and you are going to copy the data from the NPK, and you're going to copy the data for the control side by side. All right. Next thing you want to do is you're going to go into data on the top, and you're going to select the option that says data analysis. Yeah, data analysis. When you go data analysis, you're going to now choose what is ANOVA single factor, and you press OK. And you're going to select the range from what you're going to analyze. And here, for example, select this range here, and you're going to say my labels are in the first row. You have to have this one clicked here. The labels are in the first row, and you click OK. And when you say OK, there's going to appear here on the side the results from this ANOVA. The results for this ANOVA, the important thing you want to look is this p-value here. This value here that says the p-value. I want to highlight it, home, highlighted, and this p-value must be below 0.05. Yeah? If it's below 0.05, you consider that there is statistical significance. In this case, it's very significant. If it was like 0.1, it's above 0.05, so there's no significance. So you will interpret if there is statistical significance of the difference based on this p-value here that comes from the ANOVA. Yeah, and you get that ANOVA from data analysis. Okay. So next, I want you guys to think about that. When you measure your plants, you measure each plant, correct? But when you did your dry weights and fresh weights, you did it one per pot. You didn't do for every plant. You did it per pot, okay? So you maybe have NPK pot 1, NPK pot 2, and so on and so forth. And you can record the number of plants that you have. In this case, I'm putting 2 plants. It's just an example. I'm putting 2 plants for each pot. So you have recorded how much was the fresh weight on that pot. If you divide this value by 2, it will give you how much was the weight per plant. In the case I have different amount of plants per pot, by calculating like this, I will have the weight, the fresh weight per plant. Okay, not per pot, but the fresh weight per plant. And then you go the same thing for the root fresh weight, for the root dry weight, and for the shoot fresh weight. You can calculate the fresh weight and dry weight per plant. And in the same way, if I delete here this one, you can go and do the ANOVA again. Yeah, do the ANOVA again for each one of the things that you want to do. For example, in this case here, I copy the data from the shoot fresh weight and from the treatments, and the shoot fresh weight from the control. So if I select this and I do my data analysis again, it will do the same thing. Data analysis, ANOVA single factor. Now I will select the range here from the shoot fresh weight, and it will give me Maya Nova for the shoot fresh weight, and the p-value here should be also below 0.05 to be significant. If it's above 0.05, it means there's no significant difference between the treatments, okay? All right, so you can do this for the fresh weight, dry weight, and you can express your graphics like this, yeah? And if there is maybe statistical significance, you can put an asterisk on the top here, meaning the asterisk is signifying that there is difference between the treatment and the control. Any question about this so far? How to treat the data? About the fresh weight and the dry weight?
Doctor, we didn't do for each pot. We didn't for control and for the treatment only.
Yeah, but you have each pot, you have the weight, no? Each pot was one bag.
Yes, yes, we have.
So you have the data for each pot, okay? So you have NPK, pot one, or maybe in your case is control, no? Biochar, your group. In your case will be biochar and no biochar. Control will be the no biochar, and you have pot one will be one bag, pot two will be another bag, but each pot will correspond to different amount of plants, no?
Yes,
So
doctor.
yeah, so I want you to go, and after you have the fresh weight and after you have the dry weight, you have to divide by the number of plants. In this case, I'm dividing by 2 because my example says I have 2 plants on my pot. But in your case could be that one pot has 3 plants and the other one has 2 plants. So you have to reflect the weight per plant, okay?
Okay, doctor. Thank you.
Is that clear? Okay. And you can do statistics in the same way using the function in Excel. I have another video which shows also doing the statistics and making these graphics, bar charts in Excel. That video is on the Moodle in the beginning of the course, yeah, how to show your data. So this more demonstration about this, it's also on the Moodle. Now I'm going to show you guys about the calculation that you have for the ash and the nutrients. No, that's the important thing that we calculated 2 weeks ago, and you're going to have that on the reports. So this is the biochar, the group, yeah? Biochar root and biochar shoot. So this will be not control but treatment. Yeah, it will be in the other way around. The control and the treatment is the biochar. So you have biochar root, biochar shoot, control root, control shoot. And already you're showing me probably the average from all the plants here. No? The average from all the plants, that is fresh weight in grams, and for the biochar, fresh weight in grams here again. And you have that the dry weight also for shoots and for roots. Yeah, you have root here, shoot, control root and control shoot, and you have for all the treatment the average per plant. Fresh weight, dry weight. So first of all, if you have fresh weight and dry weight, you can calculate here what is the percentage of dry weight, yeah, sorry, the moisture content. So if you get the fresh weight moisture will be fresh weight, let's say 100 first, 100 times fresh weight minus dry weight divided by fresh weight in this case. That will give you 21% moisture in this treatment. And then you can go for other treatments showing how much moisture there is. There was 21 but all the others are showing more moisture, 68%, 59, 64%. Okay, the ash content will be the same thing. You have the grams of ash, but also you have the amount of the dry weight. So you can do 100 times the amount of ash that you have in grams divided by the dry weight. So that gives you the percentage of ash on your plant material. Yeah, the percentage of ash. So you have 10% of ash in this biochar root, 17 on the shoot, 27% on the control root, and 15 on the shoot. Here you don't have replicate, so you cannot do statistics on this, but you have, like say, the average value. Okay. Next thing you have is the potassium reading. The potassium reading here is showing in ppm that you take in, but you have the dilution. First, you have that the dilution for this first treatment was 10 times. The second one was 30 times. This is the number that you guys gave me. If it's incorrect, you can adjust this. 30 times, and the dilution factor for the other two also 10 times. So meaning you took 1 ml, you diluted in 10. Yeah. In this case here, 1 ml and you diluted in 29 ml. So it's 1 in 30 and the other ones are 1 in 10, the dilution factor. So I get my reading already in ppms for the potassium, but I want to transform this by multiplying by the dilution factor. So the reading in ppm here in blue multiplied by the dilution factor will give me the concentration on the extract that I filtered, the extract that came from the filter. Yeah. So this is the amount of ppms of potassium, milligrams per liter, in the extract that came through the filter when we have that, when we diluted the ash in acid. After we diluted in acid, we filtered, and this is the concentration we find on that extract. Okay. So that.
Doctor, you are not sharing that Excel.
You're not. Oh, you're not seeing that one.
No.
I will. Let me go back. Let me go back again, and I have to share maybe another window. Stop presenting. Let me go back and explain again because the Excel was not shared. Window, and let me go here. All right. Can you see now?
Yes.
Yeah. So I will go back and explain again because it was not showing the Excel. No. So they have the average here for the biochar root, the fresh weight, and the dry weight. It's clear now. You can see, right? Just confirm to me that you can see the Excel.
Clear.
Okay. And they have the biochar shoot, also the average for the fresh weight and the dry weight. And for the control, they have also for the root and the shoot, the fresh weight and the dry weight. Now with this, you can calculate the moisture. 100 times the difference between the fresh weight and dry weight. So the fresh weight, 0.52 minus the dry weight, divided, this is the amount of water that was, yeah, how much was lost during the drying. So if you divide that by the original fresh weight, you will get the percentage of moisture. So in this case here showing 21% for the first one, and I can just drag the formula by selecting the dark cross in the right lower corner, and I drag that down. Okay, and to lower the number of significant numbers, I can come here and click on this icon here, decrease decimal, and it will show me this is the percentage of moisture. The ash content, you can do the same thing. So this is the grams of ash that you get from this dry material. The 0.41 grams of dry material gave you 0.0438 grams of ash. So how much does that mean in ash content? it means that you have, in this case, 10%. So I multiply 100 by the 0.438 grams of ash divided by the dry weight will give me what is the percentage of ash. So this is 10% for the biochar root, 17 for the biochar shoot, 27% for the control root, and 15% for the control shoot. Ash content you expect to have between 3 and 7%. So these numbers, they look a little bit high, but I will not criticize that at this moment. Typically you will have ash percentage like between 3 and 7%. Unless the plants were very dry, or I don't know, even the ash content will not be so much influenced by the moisture. Anyway, let's say this is the numbers, you work with what you have, no? Okay. From the moisture content calculation and the ash is clear. If it's clear, I will move for the next one. All right, I assume it's clear. So let's move for the potassium reading. This recording I will put on the Moodle also, yeah, the recording of this calculation, so you guys can revisit this for your projects. The idea is that you show graphics like this, where you have the treatment for the root, the shoot, the control for the root, and the control for the shoot. And you can do this, and you can show what was the behavior of different things that are happening. Okay, so for the potassium, let's start for the potassium. This is what is written here, is the reading that came out of the flame photometer. So that reading that comes from the flame photometer is it's in ppms already. Ppms means milligrams per liter. But you have several dilutions that happen on that process, yeah. So that dilution here for this group, it's shown here on the right. So there is 1 ml in 9, meaning 1 to 10 dilution on the first treatment. The second one is 1 ml in 29 ml, so 1 to 30. And the second one also 1 in 9, and the fourth one is 1 in 9 also. So meaning 1 to 10, 1 to 10, 1 to 30, 1 to 10, and so on and so forth. Maybe for your group this will be 1 to 100, depending if you diluted more or if you just kept 1 to 10. Okay. So first calculation I put here on the bottom. So I will highlight this one here. First calculation, I'm just multiplying the reading by the dilution factor, and that will give me what was the concentration on the acid that came from the, when you filtered. First you suspended your ashes on the acid, then you filtered that acid, and what was the concentration on that 10 ml of acid that you added to the ash. Okay, so my concentration here saying 280, 3300, 80, and 830. This is the measurements that were taken for the extract. Yeah. Now what I'm saying now, the next calculation here is what is the total milligrams? What is the total milligrams? The total milligrams will be, let me put here in another color. The total milligrams will be, I have this concentration, I need to multiply now by the volume, because this is milligrams per liter. If I multiply by the amount of liters, the liters will cancel each other. So here is, I have 10 mLs, so I multiply by 0.01 liter, okay? 0.01 liter, and that will give me 2.8 milligrams in total in my extract. From my ashes, it was containing 2.8 milligrams in total of potassium in my ash, yeah? And you can go on calculating for all the other ones the same way, just multiplying by 0.01. So far so good? So you need to continue here, multiplying by 0.01. Now the next thing is, this is the total milligrams, so you can divide now these total milligrams by the dry weight, but I want my dry weight in kilograms, and my dry weight here is in grams. So there's a factor of 1000 here, and I multiply this by 1000, and I divide here by this value on the of the dry weight. Okay, so this way I will get the correction per kilogram and not by milligram. Okay, by not by grams but by kilograms. Sorry. So you just have to mimic this formula when you go for your data and do it in the same way. All right. So this is the total amount of milligrams per kilogram of dry weight that you have on your plants. And if you want to transform from milligrams to kilogram by percentage, what you do now is you have a factor of 10,000. Yeah. Each milligram per kilogram is by a factor of 10,000 becomes 1%. So there is here a divide that value by 10,000 and you will get that in percentage. So let me take off here. So what's actually happening here is what you are saying is on the first treatment here, which is biochar root, you have in the plant dry weight 0.68% of potassium. In this one, which is biochar shoot, you have 1.6% of potassium in the dry weight of the plant. And the control root, you have 0.7% of potassium in the plant material. And in the control shoot, you have 0.43%. Okay, so I will share this Excel, and I will share also this video on YouTube. You can mimic this calculation for your data, for your reports. And here the graphic again. This graphic now does not have the dispersion bars because this is without replicates. Yeah, this is based from all the treatments together. So I will not have the deviation or statistics on this data because I don't have replicates. If I did have replicates, I could have making here with the standard deviation and done the statistics also. So far so good for the potassium.
Yes, Dr. Khalil.
So you can come back and use this from the video, the same procedure for your calculation for the other groups also. Now let's go for the phosphorus. Yeah, they have the phosphorus reading in ppm, and okay, oh, this is, I just use one of the readings, but you can actually make here the average. Yeah, average from the two readings, average from these two readings, because you have two readings on the phosphorus, divided by 0.733 is from the curve. Yeah, from the curve. Let me grab the curve from the other analysis, and I will show you the curve again. Just a second here, just give me 1 second, and I will grab for the phosphorus the calibration curve. So you have here the, give me a second. So I will paste here on the bottom. This is the calibration curve from your data, okay? So what you have is, and this one minus this one, that you have the concentration of phosphorus here on the first column, and you have the two readings for the absorbance on this one. So what you're going to do is you have the average from the reading minus the average from the reading 0. So the 0 will be subtracting itself, so it will be 0. But you have to subtract here the average of the reading of 0.2 minus the average from the reading of 0. So it will give you, this is my absorbance, the average absorbance. This is the delta. Yeah, I've shown you. You guys did this on the other class. So this is the delta absorbance. Yeah, absorbance. So what I'm going to do with this delta absorbance and the phosphorus concentration is that I'm going to plot this once against each other. Insert, scatter, here, chart, scatter, and you see the scatter, and I will come here and I will add trend line, and I will set the intercept of the trend line for 0. I will display the equation on the chart, and I will display the R square. Okay, and my equation says 0.733, which means that my absorbance is equal 0.7933 times the concentration. So my concentration would be the absorbance divided by this number. So what I did here in the calculation is, of the phosphorus, you will see here on the top that I'm dividing that delta. Oh, there's another thing. So this is average, I didn't put here, minus the average from the or let's put already calculated here, the average from the 0, yeah, from the 0 here. So I'm subtracting the blank, also subtracting the reading of no phosphorus, only water, and I'm dividing that value by 0.733. That will give me the concentration of phosphorus on the extract. Okay, so the concentration of phosphorus when I read, now, oops, I did something. Sorry. The concentration of phosphorus here, and what I'm going to do next, I'm going to multiply this by the dilution factor. Yes, you have the dilution factor here. I'm going to do the same thing that I did with potassium. I'm going to multiply it by the dilution factor, okay, for the phosphorus, and that will give me this milligrams per liter on my acid. Okay, next I will do the same procedure with potassium. I had the milligrams per liter. Now I'm going to calculate the total milligrams. What is that? You multiply that by the amount of liters. So my amount of liters was 0.01 liters that I add from acid into my ash and I filtered. So that means in total in my ash there is 0.03 milligrams of phosphorus. Next thing, I'm going to calculate in milligrams per kilogram. There's a factor of 1,000 from grams to kilogram, and I multiply by this and I divide by the value of my dry weight, and then it will give you milligrams per kilogram on my dry weight. And if I want to calculate for percentage, I just need to divide by 10,000. It will be the same thing. But in this case, because the percentage is so low, you can actually forget about the percentage for phosphorus and use milligrams per kilogram. So this here, this was for potassium, and now I can make it for phosphorus, for example. If I just come here and, for example, give me a second, take this value and drag to my, this is what's happening. So I'm showing here that my calculation is giving that there is way more phosphorus in the control roots. Yeah, so probably maybe there is a mistake here on the control roots, because the control should not have more phosphorus than the biochar. But in the case of the shoot, there is more on the shoot than the control shoot. You know, the biochar shoot here, comparing to the control shoots, there is more. But in the case of the roots, it's showing much more on the control roots than in the biochar root, for some reason. Maybe there are some soil particles that was attached to the roots. So when you did the procedure, that soil particles kept the phosphorus and gave some mistake on that reading. That could be the reason, but I'm not sure. Yeah, I'm not sure. So The phosphorus follows the same procedure as the potassium. The only difference is before you do the calculation of the dilution, you have to calculate from the calibration curve that is here on the bottom. So that calibration curve will give you, even the calibration curve is not so good, but let's say we accept it as it is. And the extinction coefficient is this number here on the calibration curve. So you need to use this extinction coefficient to calculate your concentration, and then from this concentration you will move through the dilution and calculate how much is the concentration per weight of dry weight of the plant. Yeah, and that can be given either in milligrams per kilogram of dry weight or in percentage. Yeah, or in percentage. And this is what the data that I expect you to show in your reports. You know, this is why I wanted to do this event today, because if I don't show you this in detail for you guys, probably some of the reports will not be correctly calculated. So this is what I wanted to show for you. Any questions? No questions? All right, so after I finish here, I will upload the video in YouTube and put it on Moodle also, the calculation for the reports, and you can follow the same calculation and make graphics here. For this one here, which is the phosphorus, for example, you can go and just say phosphorus in plant tissue. And you can add here, for example, in the graphic, also the axis labels, no axis titles, and you can put axis titles will be, this one will be P in milligrams per kilogram of dry weight. Yeah. And your axis will be with the unit there, and I know what it is. So you can show this type of graphics in your reports, and I will understand that you correctly evaluated what was the concentration on your plants. All right. So if you have questions, now it's the time. Otherwise, we will finish now, and I will upload this to the Moodle, and you guys can follow this procedure for your reports. The reports, I need your reports by Monday next week. The presentations will be Wednesday next week, okay? And Monday I will come and I will do some explanation about the exam if there is any need for that. And Wednesday we have the presentations of your projects in the lab, yeah? And if you want to make a video about your project instead of making the presentation, I even prefer, because we can upload those videos also and leave it for the students on next semester. But if you don't want to, you can bring a PowerPoint and make a presentation about your project. All right? Any questions about the project?
No, Doctor, everything clear. Thank you.
Everything clear. All right then. Let's finish the session now and have a good one. And we meet you next week on the class for discussing the exam. And also, if you have any other questions about the project, we can clarify on Monday. Yeah, but I expect you in Monday to deliver that reports so I can evaluate and grade the report before the Thursday. Yeah, Thursday I need to give you the grades up to 60%. So I expect the reports on Monday. All right. If no other business, so I will let you go now, and I will we interact by email on this. All right. Thank you. See you guys.
Thank you, Doctor.